In this video, we will see how to find trigonometric ratios for angles greater than 180 degrees. An angle which is greater than 180 degrees will be an angle like this, and it will fall on the third quadrant of the graph. So it's 180 degrees, and then plus this angle over here will be angle theta. So let's see how we can find trigonometric ratios for this. Consider this right angle triangle sitting inside a unit circle, and its origin is at O with 0, 0 as its origin. Okay. Now, if P is a point on the unit circle, and if we rotate this point P along, the circle, then the triangle is expected to change its shape. So let's do that and see. So you notice that the point P is being shifted, then the triangle is changing its shape, it's becoming shorter, and this length is becoming longer. Yeah. So when we move it to the other side of the second quadrant, then what happens is, in the second quadrant, it starts to form a mirror image. We have seen this in our previous videos. So the angle is theta. It remains here. However, the triangle is on the other side, and it forms a mirror image. And to explain this, we can consider this a young man playing basketball, and you have a mirror here on the y-axis. So a mirror reflection is being formed. So this reflection is what you see here in the in the second quadrant. All right. So if we're going to move it further on, and if I'm going to bring this point P all the way here, then what would this triangle mean? Or what would this angle 180 plus theta that we have here would mean? Notice that our P has been shifted all the way from here. We have moved the P to here. Okay. So if this is the P that we have, which is shifted from here to here, and our theta has now become 180 degrees, what is this image that we see here? So I'm going to explain this to you using the same illustration here with the young man. Now consider that he was playing basketball by the swimming pool. So you have the pool, and at the end of the pool, the mirror was there. So when he looked into the mirror, he sees himself. Okay, but mirror is not a reality, it's a virtual, and also it reverses. So that is why the image that is on the second quadrant can be illustrated using this mirror image here. If he sees through the mirror his reflection, and then he also looks into the water, the reflection of his own image on the water body, what will he see? He will see an image like this. Now notice, this image would be both vertically and horizontally flipped. When I say that, it is vertically flipped because here the y-axis is positive and here the y-axis is negative. So you will see his image vertically flipped. And also you will see that his image is horizontally flipped. So for example, you'll see this shoulder here, and then you'll see the ball here. Now I want you to look into this image and the way these two lines are going into the third quadrant and making a reflection. So whatever is here goes along the x-axis here, and whatever is here goes down all the way here. So it's like, you know, a double flipped image. So if this is the image that we have here, what is its, you know, actual image here? Okay, so let's find that. So its actual image here will be the same angle theta and the point P, which will be the hypotenuse of this triangle. And let's say this coordinate is xy, then this coordinate will be minus x minus y, because this height will be y, same as this, only that it will be negative because it's on the negative side of the y-axis, and our x value will be equal to the x value here, but it will be on the opposite side, so it is negative. All right, so that's the meaning of an angle which is 180 plus theta. So next time you see this angle, I want you to visualize a triangle like this and know that this is not the real image. You have its original image in the first quadrant, and you know you're going to do your calculations from here. All right, however, let's now see what happens to the coordinates and what happens to our trigonometric functions. Okay, we know that our x and y axis can be, our xy coordinate can be written as cos theta sine theta, which is this point P can be written as cos theta sine theta. Okay, and our point here P1, P2, which is with reference to angle theta 1, can be same way written as cos theta 1 and sine theta 1. So let's do that, cos theta 1 and sine theta 1. So cos theta 1 is equal to minus x, sine theta 1 is equal to minus y. Okay, now let's continue to find, you know, our exact values. So sine 180 plus theta, which is this angle here, is equal to, this angle is theta 1, so we are saying sine theta 1, which is sine 180 plus theta, is equal to minus y. Okay, so we bring this minus y here, and we know that y is sine theta. So substituting these values, you get sine 180 plus theta is equal to minus sine theta. Now let's find cos 180 plus theta. So cos 180 plus theta will be equal to theta 1, which is cos theta 1, and that's equal to minus x here. So we bring that value here, and also you see that x is the same as cos theta. So we substituted that value here. So now we have cos 180 plus theta is equal to minus cos theta. Let's now find tan 180 plus theta. So tan 180 plus theta will be equal to sine 180 plus theta divided by cos 180 plus theta. And we know from our first two equations, sine 180 plus theta is minus sine theta, and our cos 180 plus theta is minus cos theta. So minus cos theta divided by minus sine theta divided by minus cos theta will be equal to plus tan theta. So we have all our trigonometric functions for sine 180 plus theta, cos 180 plus theta, and tan 180 plus theta. Right. So in the next video, we will see how these images are formed on the fourth quadrant, and we'll also see how to calculate these trigonometric ratios. Hope you enjoyed this video. To see more of these videos, kindly subscribe. And also, if you have any comments, please, you can drop it at the comment box. And if you have any specific videos that you would like me to make, you can also mention that. Thank you for watching.